Hello everyone, Namaskar, Sawadee Krap. I welcome you all to the special session of the Executive Diploma 360 degrees, which is focusing on the rubber industry, technology and management. This is a 3-month-long online diploma program focused on the non-tire rubber industry. As part of this program, the participants are required to make presentations based on their experience and expertise. And today we are with Mr. Simon Delcour. He's a quality manager at Van de Wero Rubber and Plastic based in Belgium. And he's going to give a talk on the custom fabrication of extruded rubber profiles. Simon, it's over to you now.
Hello, welcome everyone. Today the topic I'm going to discuss is the custom fabrication of extruded rubber profiles. So the overview of this presentation is I will give a short introduction about the company, about Van de Wero Rubber, how and why we make our profiles, why do we need the custom fabrication, why do we need to offer this solution to our clients. An important aspect of the custom fabrication is the cutting operations, and then I will explain the different methods that we can use to offer these custom-made seals, and with some tips about good practices and safety and risks tips. First, a small introduction about the company Van de Wero Rubber. So we are located in Belgium. We are a rubber manufacturing and plastic company. So we are a transforming business. So we buy the raw materials, we source the raw materials, we compound it ourselves, and then we do the multiple processing windows. So we have extrusion lines, we can do injection molded parts, and we can do a variety of operations to deliver a client-specific solution to the customer. Some of our references, so we are located in Belgium, Western Europe. We have one production facility, but we deliver worldwide. So the half of the output is for Belgium, and 45% is exported outside of Belgium. So we deliver to America, Canada, or neighboring countries, to even further in the world. In what type of sectors we are available? So we have a lot of products in the building and construction industry. This is mostly for curtain wall glazing profiles, also verandas. So for everything where there are windows, you can find seals in the corners, and that is an active session we have. Also for the agriculture applications, we make a lot for the agriculture machines, also automotive for the weather sealing, and a lot for the construction equipment, which will be the main focus of the topic today, for the cabins that are used in the heavy machinery. This is an important topic. Some other nice sectors are, for example, in the sport and gymnastics equipment, where we are making injection molded rubber parts for mounting the equipment so that the athletes have good support on their equipment. So, but the topic of today is the custom fabrication of extruded rubber profiles. So on this image, you see the classical example of a custom rubber gasket. This is a cabin door of heavy machinery equipment, and it is necessary to provide a sealing solution for this type of shape on the door. So why do we need to offer this type of solution? It is to make a connection, especially for the corners, to make a sharp 90-degree angle or a very tight curvature, so that you can make these corners without that there is a bulb collapsing, and that you have a good sealing performance, especially in these tight spaces. And the goal is to deliver a ready-made profile that the cab manufacturer or the assembly production plan just takes the profile out of the box and is able to install it on the cabin. So here I'd like to show you an example. So this is an example of some finished rubber products, so to show you the way that packaging is also very important. And here you see my colleague working on testing his design for making this custom seal gasket. So when we get a new project or we start a collaboration with a partner of us to develop a good sealing solution for their new project, one of the best ways to start is to let the cabin come to us, and then we can immediately make samples and prototypes and test it ourselves before we send the cabin back to them, and they can also do their validation tests. For this cabin, there were some particular challenges because there was a very specific corner that was very difficult to make, but we are in the process of validating this profile further and making some modifications to get the good sealing performance. One of the most important aspects in this custom fabrication is the cutting on length, because so we extrude the co-extrusion profiles on our co-extrusion line we have here in-house. So we have full control on all the profile quality for dimensions, for specifications on compound, on mechanical testing results like compression, insertion, clamping forces. But the cutting on length is very important. This is a custom action that we need to do because the cabin doors have a specific dimension and we have to fit the frame and the assembly correctly to the design of the cabin. Also, the angles are very important to consider the right dimension so that the sealing gasket has a good fit on the cabin. Here on the image, you see an example of a splicing corner. This is a sealing profile which has adhesive tape and a bulb. You see the compression bulb on top. This is for the when you close the door. So the fitting of the parts is very important, but when discussing with the customer or the clients, it's very important to have clear agreements, especially for the measurements. The measurements of the length is one of the most critical parts in this type of business because it is easy to get confused and you have to make very clear drawings and practical testing, because rubber remains a flexible material, so length can be a discussion point, especially when you are delivering all over the world, when you get to a colder or a hotter climate, and also the factory mentality is different when they are used to not pulling on the profile, or when you have to put a little bit of effort into assembling the profile. This can all make quite differences, so you need to have make good agreements with the customer. For this cutting on length, it is necessary to have a cutting installation. You need to make a saw installation which is able to make the angle cuts and to make nice clean cuts through the rubber profiles. So you also need tooling for this. For most of the splicing technologies, you also need tooling for welding, and mostly you have the cabin door, you have one on the left, but you also have one on the right side. So for the cabin manufacturers, we mostly make two different versions, but for this you need to make some changes in your process because you cannot swap them identically, because you have a left and a right side, so those are inverse symmetrical. So that is also an important consideration you need to make. And also for the article code and numbering, is very important to have a clear communication on which side you are making, because you would think you make equally parts for the left and right side, but that is not the case. So when an order comes in for only one side, you need to make sure you are able to produce the correct one. The cutting method that is used for this, so this is a typical miter saw, and this is used for the rubber profiles. So you can have different type of blades. You can have with no teeth, you can have with some teeth, you can have a lot of teeth, you can have diamond plated. So this depends on the type of the profile, because some profiles don't have a metal insert, some profiles have a metal insert, some profiles have a metal wire insert. So that depends on what gives the best cutting results. and it's important that you can adjust the angle. So you see here, this piece you can slide back and forth to determine the angle cut, and the profile is placed on the saw, and you need to foresee tooling, cutting tooling to mount the profile inside. So it's very important to have a fixed profile shape, because when you start the saw cutting, the profile will tend to move, and when it moves during the sawing action, you will have a deformed shape, and this might not seem as much when you're doing the action, but when you're going to the quality control of the finished part, you will have so easily see some defect where you will have some thicker part or some deformation on the splicing plate. So it's very important to maintain the condition of the blades. You need to keep them very sharp. With the dull blade, you can get a clean cut. And also it's possible to add some lubrication. So that is a custom modification, that there is an automatic lubrication added to this type of saws to have a very nice clean cut. It's very important also to always consider the safety. You have a safety handles to make sure that no one gets hurt when you're doing the sawing action. So this is mostly for serial work when the volumes are already bigger. When we need to do prototyping or special testing or something, it's mostly used with a special cutting scissor that is working very well for the rubber. So this is a standard model, but there exist models where you can also adjust the angle, and you have a longer knife, so you can cut also a bigger profile. Now we are going to discuss the splicing methods. So there are 4 methods we consider as an option when we need to deliver a custom fabricated sealing gasket. So we have the hot splicing method. There is a cold splicing method. So the difference between these two will become clear in the next slide. Then you have cold bonding, which is also seen as a gluing method, and corner injection molding. Each of these methods has its own advantages, and sometimes the choice for a project it depends on the profile specifications and the possibilities to make a choice for one of these methods. Firstly, we are going to discuss the hot splicing method, which is one of the mostly used. So you are in fact, you start from the rubber profile. So mostly in our cases, this is EPDM co-extruded rubber profiles, because the profiles need to have the ozone and the water resistance and the sealing performances of dynamic applications when you're installing cabin doors. So this is a typical machine. What is the principle? The principle is that it is working with hot molds. So the molds are on a temperature of 180 degrees, and you are also using a piece of uncured rubber film. So normally that is inserted with the roll on the top. The profiles are already cured, so they are coming from the vulcanization line. But in this molds, this is an example of the mold, so you can easily insert it through the one side. And on the other side, you have an identical pair, and you can make also multiple cavities, so you can increase your output for the cycle time. So these molds are heated, and then you put a piece of uncured film together, and you mount the profiles, and then you close the machine. The machine will then use pressure, heat, and time to vulcanize these two parts together for a certain amount of time, and then you will have a good connection between the two profile ends and the piece of uncured film that you have put together. So this is a higher cost method, because you, of course, you have to develop cool tooling cost, but you're also with the cycle time, because you have to vulcanize the profiles. You have to vulcanize this piece again, so the mold has a specific cycle time. Then another method is the cold splicing method. So the difference here is that the molds that you saw in the previous slides are cold in this situation. and you are not using an EPDM uncured rubber film. Mostly it is a thermoplastic film of a PE welding foil that is specially formulated for these type of applications. Why is this method sometimes preferred? This is for profiles which have adhesive tape. So the adhesive tape you saw in the beginning of the slide, so the orange liner, yeah, that cannot withstand the temperature of 180 degrees of the hot splicing method. So then you need the cold option. So the principle is the same. You mount the profiles in the two links with the cavities, but then they will be heated for a short time mostly by means of infrared lights. So only the ends will be heated very short, and the PE foil as well, because it will melt, and then the molds will close, and for a certain time, but not as long for compared to the vulcanization of the hot splicing, and you will have a good connection. Then you have a better connection. Also here you have a tooling cost for the molding application. Then the third method is the cold bonding or the gluing. So this is a most labor intensive process. It is good for prototyping and short volumes of very specific one-time projects where the investments in all the tooling costs is not efficient. The type of glue that is used for adhesive rubber is the cyanoacrylate glues. So they make a very good connection and they have a fast reaction time with rubber molds. But this is also mostly used if touching up of the earlier methods when there is a small defect. But we are working from the principle that you need to design your process and the profiles and the toolings so that you receive a good weld at the end, which does not require glue. So glue is not the standard solution to make a good connection. The advantage of this is that you don't need tooling costs, but it is a labor intensive process to work with. Also, you're working with droplets of glue on small amounts on droplets, so you have to pay attention. The operators have to pay attention when they are working with this type of glue, so that their skin is not fully formulated, and also you have the tendency to dry out the glue quicker, but you have to pay attention that you don't get droplets, especially in the eyes, because that is not is very harmful. Then the last method is the corner molding. So this is a more difficult and complicated process. Then you are able to make special shapes and corners. This is most occurring in the automotive industry when they are for glass encapsulation, for example, but also to make a connection between two seals in a difficult spot. What is special about this technique is, so you are inserting also again the profiles in the tooling mold in a special designed mold, and then you are going to inject a special compound, mostly it is a TPE special compound, which is able to bond good to EPDM and which is quite soft, because yeah, mostly it is a solid corner that you are getting from this result, and this can lead to pressure increases in the corners when the installation of the gasket is taking place. But this offers some very nice options that you can use. You can use it to make very special shape. The connection can be bigger than a few millimeters, so you can make a special corner or a special transition from one profile, so it doesn't need to be the same shape exactly, or you can twist it, or you can orient it differently with this type of method. In the previous methods, you have the mitred corner and you have the splicing line, which in the end will remain the most delicate section of the profile. That will remain the weakest link. So when you put a lot of force on it, it will break. You are possible to damage the profile, while you are not able to damage a co-extruded rubber seal when you pull on it. But with this method, you can displace the stress that would be priority maximum in the corner. You can, when you add a little bit more material, you can displace this line, and then you have the stress in the full amount of the rubber you injected, and the weakest part will have shifted a little bit. So this is the methods to discuss when you are talking about making the connection between two profiles that were sawed on length or cut in a specific angle. But for the custom fabrication, there exist also some other options. So mostly, if there needs to be for the corners some reinforcement or some additional requirement, it is possible to insert a type of tubato. So you see here, this is a co-extruded profile with a compact and cellular section, but there was a separate cellular extruded tube piece inserted in this profile. This is to offer extra stability in the corner to prevent collapsing. But you need to make sure the stress will not be too much, because they still need to be able to close the door effectively. When this is placed at the ends of the connection, yeah, they will also be welded together, so they will not move. But sometimes there is a specific spot along the length of the profile where there is a requirement for this type of tubato, and then you need a fastener system, and this is done with a buttonnier system. So you're in fact adding a little button, which is a plastic material, and you insert it with a sort of gun with a needle through the profile, and when it's done nicely, you almost don't see it. So it's very smoothly inserted on the profiles, and this way the tubatos are remaining in position without any problem. Additional actions can be sometimes you remain with an open end, so the profile sealing gasket is not closed. You remain with an open end, and then you need to add rust protection. This is mostly, of course, with profiles which have a metal insert, for example, when you use a clamping section. Also, pull tabs. Adding pull tabs is for adhesive profiles. This is to easily pull off the liner so that installation operators don't have the need to search for picking off the orange liner, so that they can have a smooth installation of the adhesive profile. So like I said, when you have an open end with the bulb, there need to be no holes in the profile because the air can escape. But when you are working with a closed system in the co-extrusion of the profile production, you need to add drilled holes to allow the air to escape smoothly when they are closing the door. Otherwise, the client will have problems when they are trying to close the door, that it is not going as smoothly as they want. In the following slides, I would like to share some good working practices, because it is quite a labor-intensive process. It's all manual, and yeah, there come a lot of different aspects into play to make a good end product. So here I'm going over some good working practices. So when you're working with setting up a sealing gasket, it exists out of multiple lengths and angles. So when you are preparing your welding production, all the parts are cutted and measured beforehand, but you need to make sure you do not mix them up together. This is a problem that could occur. So you need to make sure every product you have cutted is identified and is placed on a specific location, so that when the operator is starting his welding of the gasket, so that they cannot miss an error to make the frame, because otherwise it will not fit in the end. So another good tip to prevent these mistakes is that every caliber, so we use U metal frames to put the profiles inside, and these are put with the prototypes to saw on length, and then when it is validated, all the toolings and calibers are marked with the profile identification and their respective length, also with the angle identification, so that all the machines can be adjusted appropriately, so that there is no mistake when you're preparing your parts. Also, it can become a quite cluttered environment, so it's very important to use wax and to use a suitable system. So mostly when you are working on these type of machines, you have made a connection between two profiles, and you make a full batch, for example, of 50 pieces, and then you need to make a different angle, but then you need one of the two profiles which were already together, you need to put the other end again into the machine. So you need a good system where you can effectively hang and store your profiles which are which already have a connection. And also for the finishing, you need to have a rack so that you have a good overview of your production environment. So also important is to prevent entanglements. So when you're working with multiple cavities of the molds, so that you're not putting the wrong end of the profile in the cavity, because then the profiles get mixed up, and especially when you are closing your ring or your sealing, when there is a mistake happening and you weld them together and there is a profile in between, you cannot get it out anymore, so you need to destroy your sample and do it again. Also, especially with some longer parts, when you're working with some several meters, the parts can lay over the floor, so it's important to avoid tripping hazards so that no accidents are happening. Every profile needs its specific tooling, because it is a specific design to fix the profile for the cutting, and especially for the molding as well. You need to have a good caliber for placing the profile inside, so you get a lot of variety of molds and tooling. So you also need a good rack for identification, so you don't lose time for searching the toolings. And also for the same profile, when you're working with different angles, you also need different toolings to use this. Then another important aspect is also the packaging. So in the previous presentation, we discussed about co-extrusion packaging. So it is not as it is even more complicated than co-extrusion, because you have to limit the weight in the boxes. You limit the parts per boxes, because you want to prevent the parts damaging each other because of the amount of weight, and because you have a delicate part, so every part has a weakest link, especially at the splice, so you do not want to put stress on it. So you need to think about with the client to accept how the packaging will occur and how you will place effectively the finished gaskets in the boxes. Also to discuss with how does the customer take the profiles out of the box, because some customers tend to be quite heavy with the profiles, and then the gaskets tend to be damaged, but with a good system this can be solved. In this slide, I would like to tell about the cost calculation. So when you make a co-extrusion profile, so you can do a cost calculation for the extrusion. So that is in fact the base starting point for your material input for the custom fabrication process. And then you need to take into account all the following steps to determine a price, so that you can make an offer to your client. One of the most determining how much work you will have on making one sealing gasket is the number of welds that is in the frame. You can make 3 welds in the frame, or you can have sealing gaskets which have 5 welds in the frame. Also, so this determines the number of lengths of profile you need to saw. So this determines the cutting action that will require. Also the differences in length. If you need to change from a short to long length, it takes different amount of time. Because long lengths take some longer work, but if you need to change a lot and change also the angles all the time, it takes a lot of time to set those up correctly, and every time taking the quality control to make sure that the production of the length is correct. There is a variety of tooling costs. So you have your extrusion profile, so you have your extrusion tooling that you need. But when you want to make a custom fabrication gasket, you also need tooling costs. You need to make length calibers, you need to make cutting molds, you need to make welding molds, and those are all not so easy. So you need special equipment to do that, and those are all, it can get quite costly. The number of cavities that determines the amount, the output you can get from one machine, and especially the cycle time of the type of process you have chosen. If you choose a hot splicing method, you will have a cycle time to vulcanize a profile. Is it a cold splicing? Then you have a faster cycle time. With gluing, then you have limited the tooling cost, but you have a lot of labor, manual labor cost to make some parts. And then also to consider if there are additional actions required to finish the profile according to the customer specifications. There are, in this slide, I'd like to point out some safety risks and hazards that can occur in this environment. The mold, when you're working with hot molds here, you have to pay attention to the heat because you can easily get burned. So you need to use gloves, and also the profiles can be hot, and also the cold splicing method when you just take them out of the machine. Also to protect your hands, because the molds have very sharp edges, especially, and you have to work closely to the molds and closing and inserting the profile, but you have to pay attention to the sharp edges that your hands are not getting cut up. Of course, safety shoes and work clothing. Also, an important aspect is that there is enough lighting foreseen in this work post, because it's very important that the operators are seeing what they are doing, and the quality level is determined by, is in the details, is really in the splice level, to make sure that there is a good connection with no holes, so that you can guarantee the water resistance. Especially pay attention to your hands when you're setting up the tooling, changing the tooling, especially when exchanging the cutting action with the saw blade. You also have to make sure that everything is adjusted so that the spinning blade is not going straight into the metal, so always carefully check your setup. In this type of environment, it's important to have one person per machine, because it tends to be easily when there is a problem, or you want to check that you are working with multiple persons at one machine, or that one person comes look at the machine, and you tend to put your hand somewhere, and you have the danger of touching the machine when the other person is performing an action. So it's very important that if you are with multiple persons, that you do not interfere with the actions of the operator, so you do not get harmed in the process. Especially with the glue, I would recommend wearing safety goggles, because you do not want to get a droplet of this glue in your eyes. And to up the cycle time that is necessary for gluing a connection, they tend to blow on this droplet, but then you need to make sure you're not blowing the droplet away. As I told before, the racks that are foreseen for the system approach is also to avoid tripping hazards, so you do not have a cluttered space full with extrusion profiles on the ground. And the recommendation is also handle the profiles with care, so you do not damage the splicings you have made. I would like to thank you for your attention. I hope it was interesting for you to get some insight in the custom fabrication of co-extruded rubber baskets. And if you have more questions, you are free to contact us, and we will get back to you with the questions. Thank you.
Thank you, Simon, for an informative presentation on the extruded profiles. It's a good presentation. Thank you very much. Hey guys, that's the end of the presentation by Simon Delcour. He's a quality manager at the Van der Weel Rubber and Plastic. He talked about the custom fabrication of extruded rubber profiles. I believe that it's useful to you. If you need more information or assistance, please reach out to Simon. And if you are interested to know about techno-based diploma program, the Executive Diploma 360 program on the rubber industry technology and management, please check our website diploma.technobiz.org. Thank you all for joining today.